Welcome back. Today we're going to talk about section 7.2 of the lecture notes, which is on trigonometric functions and right triangles. So hopefully you've been studying and working on the angles from the circle I gave you from the end of notes in section 7.1. Remember, it's real important that you learn those conversions. Today we're going to add to that and look at some of the values for these functions that we're going to deal with. All right, so the first thing we're going to do is look at how we define these trigonometric functions, okay? So we all know that with the Pythagorean theorem, we have that the sides of two short sides of a right triangle squared equals the hypotenuse squared, right? That's c squared equals a squared plus b squared. So in the angles that we use, and remember the lowercase letters are the sides, the uppercase letters are the angles. So if I was looking at this triangle, I may call this side A, side B. Side C is always the hypotenuse. So this would be capital C, this angle. This would be angle B, and this would be angle A right here. And always the angles are opposite the sides, right? So we use lowercase for the sides, uppercase for the angles. A lot of times in trig, you'll also be given some Greek letters. Those also represent angles. All right, so we know that the three angles of any triangle add up to be 180. And in a right triangle, if C is always 90, then the other two angles also have to be 90 when you add them together. So these two have to add up to be 90, plus this 90 gives you the 180. Okay? So in this right triangle, we talked about we have the hypotenuse, and then if we're looking at angle A, we're going to be talking about the sides either opposite the angle or the side adjacent to the angle. Okay, so we'll be doing that as we go through as well. So those words you're going to hear quite a bit, opposite side or the adjacent side. Okay, so just remember adjacent means attached to, next to it, and opposite would be across the triangle from it. All right, so here we have our definitions for our 6 trig functions. And just remember, try not to make this any harder than it is, but a trig function is basically just a ratio. It's a ratio of 2 of the 3 sides of any triangle. So if you look at a triangle, let me slide back up here, we only have 3 sides of a triangle. So a ratio is one thing compared to another, right? So that gives us 6 possibilities for these ratios. We can look at A to B, we can look at B to A, we can look at A to C, or we can look at C to A, and then we could look at B to C or C to B. So there's only 6 possible ratios when it comes to a triangle. So these 6 ratios have names in trig, and those names are given here in these tables, and their ratios are given. So the sine function, okay, which is abbreviated SIN, if you're looking for the sine of any angle, you're going to take the ratio of the opposite side over the hypotenuse. Okay. The cosine, which is abbreviated COS, that's the ratio of the adjacent side over the hypotenuse. And then the tangent, which we abbreviate TAN, is the opposite side over the adjacent side. That's the ratio for that. So all of these are always ratios, but sometimes it's just given to you as a number because the division is done for you, okay? So these are the main 3 that we're going to use. Now, if you've learned this in high school, sometimes you learn this Sohcahtoa to help you remember sine, the letters out front. Sine is opposite over hypotenuse. So that's this part right here, right? Sine, opposite over hypotenuse. CAH represents cosine, adjacent hypotenuse. So this just kind of helps you remember these. But you do need to learn these. It's real important that you know which one is which. Now, these functions over here are what we call the reciprocals of these functions. So if you look at the sine and the cosecant, notice that their ratio is the reciprocal. Sine was opposite over hypotenuse, and cosecant is hypotenuse over opposite. Okay, so they flip. So sine and cosecant are reciprocal functions. Cosine and secant are reciprocal functions because the secant ratio is the reciprocal of the cosine ratio. And then cotangent is the reciprocal of tangent. Now most of you can remember tangent and cotangent because those words are close together. what I find that students do is they mix these up. A lot of students think that sine goes with secant because it's the same letter S, and that is not true. Okay, so you got to remember sine and cosecant are the reciprocals, and cosine and secant are reciprocals. Okay, all right. So we're going to just find a few of these values, starting off with this triangle right here. So we have 3 sides labeled with their lengths, so we're just going to find, and notice we're finding the sine and cosine tangent values of theta. So we're using this angle. So the angle is real important, which one you're using, okay? So make sure that you use, or look at your triangle and make sure that you have the right angle picked out. So if I'm looking at theta, 25 is the hypotenuse. This always is the hypotenuse, that never changes, okay? So then you have either the opposite side or the adjacent side left over. So if I'm using this angle, 7 would be the opposite side, and then 24 over here would be adjacent. So I always have some students that say, how do you know whether this is the adjacent or this? This is always the hypotenuse, so that stays that. So you only have one other side that's attached to your angle. All right, so we're just going to use our ratios and find the 6 trig functions. So we have the sine of theta. So if we look at the sine, which is opposite over hypotenuse, we would take the opposite side, which is 7, over the hypotenuse, which is 25. So that is the ratio for the sine, okay? Cosine is adjacent over hypotenuse. So we would take the adjacent side over the hypotenuse, so 24 over 25. And lastly, on this side, the tangent, which is opposite over adjacent, so that would be 7 over 24. Okay, so this is not hard, it's just that you got to remember which one's which. Now, to do the reciprocal functions, these are kind of easy because if you know these are reciprocals, you're just going to flip these. You don't need to look at your triangle anymore. So the cosecant is always the reciprocal of sine, so 25 over 7. The secant is always the reciprocal of the cosine, so 25 over 24. And the cotangent is always the reciprocal of tangent, 24 over 7. Okay, so those are kind of nice. Now you usually want to leave your trig ratios as fractions, just reduce them. You don't want to write them as a decimal, you don't want to write them as a mixed number. Just leave them in fraction form. Okay? All right, so that one was kind of basic. Just getting you used to the ratios and where they are. All right, so now here's an angle, triangle with angle theta. So now we're using this angle. Remember, here's your hypotenuse. If I'm using theta down here, then this side would be opposite, and this would be the adjacent side. Okay, so you should always know those going into it. So here they don't give us the sides, but they tell us that the tangent of theta is 5 over 12. All right, so tangent, remember, of any angle is the opposite side over the adjacent side. So we're going to label these and put them in the right place. So this is the opposite side, and this is the adjacent side. So the opposite side will be 5, and the adjacent side will be 12. Okay, so that's how I know where those numbers go. Now, I need to find the secant. All right, well, remember the secant is the reciprocal of cosine. So that would be the hypotenuse over adjacent. All right, well, I don't have the hypotenuse. I have the adjacent side, but I don't have the hypotenuse. This is a right triangle, so I can find the hypotenuse by doing the Pythagorean theorem. So I would take a squared plus b squared and set it equal to c squared. So here's my a and b. Remember, c is always the hypotenuse. So we would do 5 squared plus 12 squared, see what c squared equals. So this is 25 plus 144. That would equal c squared. So that's 169 equals c squared. Take the square root of both sides, we get c to be 13. So now we have all 3 sides of our triangle, so we can find any ratio. So now we can find the secant of our angle, which would be the hypotenuse 13 over the adjacent side 12. So 13 over 12. Okay? So this one's a little harder because we were missing one of the 3 sides, but it is not hard to find the third side of a right triangle. You always use the Pythagorean theorem. All right, so now we're going to talk about special angles. So in geometry, you learned that there were 2 kinds of triangles that had special angles, and they were the same no matter what size of the triangle. And the first one was your 45, 45, 90 triangle. So we have a picture of that here. And then I also wrote over here that we need to remember that 45 degrees, remember from section 1, is the same thing as pi over 4, right? This is the radian measure, this is the degree measure, but they are one and the same. All right, so with a right triangle of 45, 45 degree angles, we know that these two sides opposite those 45 degree angles are always the same length, right? These are isosceles triangles. So we're just going to be, for the sake of making this easy, we're going to let both of these sides equal 1. And hopefully you remember in geometry that on a 45, 45, 90 triangle, the hypotenuse is always the side times the square root of 2. That's how you figure that out. So 1 times the square root of 2 is the square root of 2. So those are the lengths of a regular 45, 45, 90 triangle. So if we're going to look at the sine, cosine, and tangent of a 45 degree angle, all right, doesn't matter which angle you pick because all our numbers are the same. So the sine is going to be the opposite over the hypotenuse. So if we look at this angle, the opposite side is 1, the hypotenuse is square root of 2. Even if you did this 45 degree angle, the sides are the same length, so you're still going to get 1 over the square root of 2. Well, we can't write 1 over the square root of 2 in trig because that's not simplified, right? We're not allowed to have a radical in the denominator. So I'm going to remind you down here to rationalize any fraction with a radical. You're going to multiply whatever the radical is in the bottom by the top and the bottom. That's how you're going to rationalize it. So in the top you have 1 times the square root of 2. And in the bottom, the square root of 2 times the square root of 2 is the square root of 4. And you can simplify the square root of 4 to 2. That's how you rationalize. So you're not going to give me 1 over the square root of 2 answer. You're going to give me the square root of 2 over the square root of 2. Okay? That is the sine for any 45 degree angle, no matter what. The cosine, since it's adjacent over hypotenuse, you're going to get the same thing. Again, the angles are the same, so that would make sense. So square root of 2 over 2 again. And then the tangent is opposite over adjacent, so that would be 1 over 1. So the tangent would be 1. Okay? So you need to know these. We're going to use these quite a bit coming up. So those are just standard 45 degree angle trig ratios that you need to know. All right, then the other special angles would be the 30, 60, 90 triangle, right? So remember that 30 degrees is the same thing as pi over 6. 60 degrees is the same thing as pi over 3. Okay? All right, so let's look at one of these sides so just we can figure this out. So we're going to look at theta. They don't really give us, on this triangle. This was just given to you in geometry that you have a nice equilateral triangle. So if all the angles of the big triangle were 60 and we split that middle one, we'd get the 30 degrees up there, making this 30, 60, 90 triangle. So we're going to let's look at the one here on the left. Okay, let's just keep your eyes on that. So this would be the hypotenuse, right? Here's the right angle. And then we have the short side and then we have the longer side. So the basic numbers on a 30, 60, 90 triangle was that the hypotenuse was always, well, we'll start with the short side. Let's let that be 1. The hypotenuse is always double the short side, so that would be 2. And then the longer side was always the short side times the square root of 3. Well, 1 times the square root of 3 is just the square root of 3. So that was how you got your sides on a 30, 60, 90. Now if you have forgotten that, then you might want to go back and rework that, but those were the, that's given to you in geometry that's what those are. So whatever the short leg is, it's always doubled to get to the hypotenuse. And whatever the short leg is, you multiply it by the square root of 3 to get the longer leg. Okay? Just like the rules up here for the 45. All right, so if we have our sides, now let's look at our angles for 30 degrees. So the sine of 30 degrees, so we're looking here, here's 30 degrees. So the sine would be opposite over hypotenuse. Okay, this is the opposite side now to 30, so 1 over 2, so 1/2. The cosine of 30 degrees would be adjacent over hypotenuse. Okay, so that would be the square root of 3 over 2. And then the tangent of this angle would be opposite over adjacent. So 1 over the square root of 3, which is not good. So again, if you rationalize that, multiply the top and the bottom by the square root of 3, we end up with the square root of 3 over the square root of 9, right? And the square root of 9 is just 3. So that's the simplified version of that, or rationalized. Okay, so there's your numbers for 30 degrees. Now we're going to do the same thing for 60. Okay, so now we're looking at this angle. So we're going to find the sine of this angle, which is opposite over hypotenuse. So that would be the square root of 3 over 2. Then we're going to do the cosine of this angle, which is adjacent over hypotenuse, 1/2. And then we're going to do the tangent of this angle, which is opposite over adjacent, the square root of 3 over 1, which is just the square root of 3. So it would make sense that these would be reciprocals, right? Because they're the different angles, so they flip-flop of where the adjacent and opposite sides are. So these numbers, all these right here, we need to know. You need to know them like you know your name, know them right off the bat. So you need to start learning those from here on out, okay? All right. So on this page, we have, again, the same pictures that we had earlier, okay? So it's just showing you we did all this together. All right, so let's look at example 3. So now that we have our sides, we can find any exact value without a calculator. Now, anytime in trig, when you're asked to find an exact value, it needs to be numbers, fractions, the ratios of these trig functions like we've been writing them. If it says use a calculator and round, then that's fine, you can use a calculator, okay? But please know, exact answer wants no decimals, okay? All right, so we need the tangent of pi over 3 minus the secant of pi over 4. So remember, you need to know what those are. If you don't know what those are, this is going to give you a hard time. So you need to know that pi over 3 is the same thing as 60 degrees, and you need to know that pi over 4 is the same thing as 45 degrees. You have to know that, okay? So the tangent of pi over 3, that means we're looking at the 60-degree angle, and tangent of the 60-degree angle is opposite over adjacent. That's the tangent, opposite over adjacent. So the square root of 3 over 1, I'll put that for a minute, and then minus the secant of pi over 4. Well, pi over 4 is a 45-degree angle, and the secant, remember, is the reciprocal of cosine. Well, cosine is adjacent over hypotenuse, so secant is hypotenuse over adjacent. So looking here, we need a hypotenuse over adjacent. So that would be the square root of 2 over 1. So I don't need to put the ones. I only put them there in case I had a fraction that I might have to get a common denominator, but that's it. Remember, with radicals, you can't add them or subtract them unless they're the same numbers under the radical, so that's your simplified version. That's exact. All right, let's look at the cosecant of 30 and 2 times the sine of 45. All right, the cosecant of 30, so we're looking up here, and the cosecant is the reciprocal of sine. Sine is opposite over hypotenuse, so we're going to be looking for hypotenuse over opposite, okay? Hypotenuse over opposite. Opposite of 30 is here. So 2 over 1. So just 2, right? 2 over 1. Now we have 2 times, and now we need the sine of 45 degrees. Okay? So this is why it's kind of nice if you know this already. So if I have this memorized, I know that the sine of 45 degrees is the square root of 2 over 2. I automatically know that. If you have to keep coming back to the triangle, you're taking time off of your test and quiz times to locate these, and that means you're going to run out of time. So the quicker you know these values, the better you're going to be. So the sine of 45 degrees, again, if you don't know it, is going to be opposite over hypotenuse, okay? 1 over the square root of 2. We know we can't write that. I showed you how to rationalize 1 over the square root of 2, and you end up with the square root of 2 over 2. That's the way you need to write it. All right, so these 2's are going to cancel out when you multiply, so you're left with 2 minus the square root of 2. That would be your exact answer for that. All right, now down at the bottom is just a table to kind of help you learn and memorize these things. Okay, so we'll fill that in together. You know, these are the things you need to know. The quicker you know this table, the better. Okay. All right, so we've already kind of done a lot of these things. We wrote them on the other pages, so I'm going to basically be filling in what we already had here. Okay, we already have all these values, so we're just going to put them in on a table where it's all together. All right, so we're going to start with the sine of 30 degrees. Okay, so the sine of 30 degrees, remember, was 1/2. Okay, again, I wrote these down here so you can look. So sine of 30 is opposite over hypotenuse, so 1/2. Then we're going to do the cosine. Let's go ahead and do all of the 30 degrees. So the cosine of 30 degrees is adjacent over hypotenuse, so that's the square root of 3 over 2. And then the tangent of 30 degrees is opposite over adjacent. Okay, 1 over the square root of 3, that's not right. We would rationalize it to the square root of 3 over 3. Then the reciprocal functions are the reciprocals. So the cosecant is the reciprocal of sine, so that would be 2 over 1. The reciprocal of secant is the reciprocal of cosine, so we need to rationalize that, so I'll do that down here. Sorry about that. The reciprocal is 2 over the square root of 3, right? That's this. But I can't write it this way, so I would rationalize it by multiplying by the square root of 3. So I end up with 2 square root of 3 on the top, and then remember in the bottom that's the square root of 9, which is just 3. So that is the reciprocal, 2 over the square root of 2 square root of 3 over 3. So they don't look like reciprocals. Okay, these are the reciprocals right here. Those look right, but remember you can't leave it like this. So that would be your secant. And then the same thing with cotangent. Okay. Cotangent would be the reciprocal of this. So let me do that up here. So the reciprocal, 3 over the square root of 3. Okay, multiply top and bottom by the square root of 3. I'm going to put equals there, square root of 3. So in the top you have 3 square root of 3, and in the bottom you have square root of 9, which is 3. And now these cancel out. So that is just the square root of 3. Okay. Now you can also look here, if I was this one, you can kind of get on the triangle, but if I'm doing the cotangent of 30, that's the opposite of tangent. So we're looking at adjacent, okay, adjacent over opposite. So square root of 3 over 1. So I didn't really have to go through this, but usually we look at these and do the reciprocals. All right, now 45 degrees. Okay, so let's remember those. The sine of 45 degrees, remember, is opposite over hypotenuse, 1 over the square root of 2. Rationalize it, you end up with the square root of 2 over 2. Cosine of 45 degrees is going to be the same thing because you're doing adjacent over hypotenuse, so still 1 over the square root of 2. Rationalize that. All right, now the tangent, remember, was opposite over adjacent, so 1 over 1 is 1. All right, now to do the reciprocals, instead of rationalizing, let's look over here and see what happens. So if I'm doing the cosecant, that's the reciprocal of sine. So look at the hypotenuse over opposite. So that would be the square root of 2 over 1, which is just the square root of 2. If you simplify, if you take the reciprocal of that, 2 over the square root of 2, and rationalize it, you'll still get the square root of 2. So the secant obviously is going to be the same. That's the reciprocal of cosine. And then the cotangent, reciprocal of 1 is still 1. So there are those values. And now for 60 degrees, we're just flip-flopping this stuff. So if we look at 60 degrees, now the sine would be opposite over hypotenuse. So that would be the square root of 3 over 2. And if I did the cosine of 60, that would be adjacent over hypotenuse, 1/2. And that would make sense that the sine and cosine of 30 would be the opposite way because you got the different sides going on there. The tangent for 60 degrees, okay, remember the tangent is opposite over adjacent, so square root of 3 over 1. Okay, The reciprocal of the square root of 3 over 2, remember we already did up here, so that's 2 square root of 3 over 3. The reciprocal for cosine was 2. And then the reciprocal for the square root of 3, remember, is the square root of 3 over 3. Right? Those are the reciprocals, so we can kind of just look back up on our table for that. Okay? All right, so these you need to know. Looks like a lot, and it is a lot, but I'm telling you, you're going to be using them all the time. So, I mean, from the beginning of trig to the end of trig, we need to know these numbers. So you need to start learning them as soon as possible, okay? All right, I think I'm going to stop here. We're about 25 minutes in, so I'm going to do the second part of the notes on the next video. So you can start working on this, continue your notes. Let me know if you have any questions, as usual, okay? All right, I'm going to stop now.